Hello and welcome to the backside of the notes. What we're going to do in this one, we're going to do something a little wild. Um, we're going to look at this problem, and right now it seems like there's nothing to do. We've got this 10, we can't simplify that. We got that 10, we can't simplify that. We've got this 13, we can't simplify that. Sneezing, edit, done. So it seems like there's nothing to do. We can't put those together because they're not being multiplied and they're not being divided. So we can't put anything together. But here's my crazy idea. I'm gonna pop it up on the screen. So here's what's going on in my head, like my thought bubble. So what I'm thinking about is, hey, I know 4x plus y minus 9x. If I put those together, those things are like terms, and we get negative 5x. Doesn't this look the same? I know you kind of have to squint a little bit, but this is a square root of 10, and this is a square root of 10. So these, in some sense, can behave like terms. Now, these two can't because they're different radicals. But if you think about, like, if you have like 4 pies and then you eat 9 pies, you're kind of like short negative 5 pies. Also, you shouldn't eat that much pie. But it's like 4 square roots of 10 minus 9 square roots of 10 means we're short 5 square roots of 10. Just like we can get that negative 5x, only if the radicals match. So if the radicals match, do like terms. Oh, I forgot the E on the like. Okay. Now that one, like they were already kind of set up to do that. This one, we don't quite see that right now. Right now, it seems like those two are different. But hey, that 48, I bet we could do something with that 48. So let's see, 48 divided by, let's see, 7 is 49. So we want to go one lower than that. So 36. How's that? Bad. How about 48 divided by 5? How's that? Well, 5 squared. Nope. How about 48 divided by 4? How's that? Success! 16. All right. So we've got 5 square roots of 3 plus the square root of 16 times the square root of 3. So we've got 5 square roots of 3 plus 4 square roots of 3. Hey, those are like terms now. We've got a square root of 3 and a square root of 3. I've got 5 apples plus 4 apples means I have 9 apples. 5 square roots of 3 plus 4 square roots of 3 is 9 square roots of 3. Check this one out. You can also use the distributive property with radicals. We are allowed to distribute a radical into that expression because 5 is a number. We could distribute that. We can do the same thing with the square root of 5. We can also distribute that. So we get 4 square roots of 5 minus the square root of 20 times the square root of 5. Well, hey, that's two radicals. We can put those two radicals together. We can't put the 4 and the radical 5 together because one of them is a radical and one of them is not. 20 times 5 is 100. Hey, the square root of 100, I know what that is. It's 10. So we get 4 square roots of 5 minus 10. Peace. All right. Now, last one that we're going to do for today, and I saved it for last because it's the trickiest. There's this idea called the conjugate. What a conjugate is the number that you can multiply in order to make something real. So numbers that multiply that can become real. So you might think about no, I'm gonna it, and I'm gonna do a thumb. Okay, there we go. Ah! There it is. So we were doing that on the front where we multiplied the square root of 3 and the square root of 3. Those two are conjugates. It's really the same number, so a number can be its own conjugate. However, these ones are conjugates of each other. 4 minus the square root of 5, that is an irrational number. 4 minus the square root of 5 is irrational. Look at that thing. So gross. But if we multiply it by its conjugate, which looks exactly like it, but instead of a minus, it has a plus. So it just has the opposite sign in between them. Watch what happens when we multiply these two numbers together. Nope, it's not going to like that. So I'm going to delete that from there. So if we multiply these two together, we get a real number. We get 11. That's real. Awesome. So we might have problems like this one, where we've got 2 minus the square root of 3 in the denominator, and that's bad. We can't have that radical 3 in the denominator. But just multiplying by the square root of 3 is not going to be enough. We need the conjugate. So we want to copy that denominator, but instead of a minus, we're going to put a plus. Now, since we did it to the denominator, we have to do it to the numerator as well. I don't know why I wrote a 9 there. So I am going to erase that. And now it's orange for some reason. Ugh. So there we have it in the numerator and the denominator. Now in the numerator, we've got to do distribution. So we're going to do 9 times 2, that's 18, plus 9 times the square root of 3 when we do this one. In the denominator, however, we have to FOIL because that's a binomial and a binomial. This is two terms, yes, they can be both numbers, being added together or subtracted from each other. And when you got binomial and a binomial, we learned back in chapter 9, you got to FOIL, so we're going to FOIL. You can also box if you like, if you're more of a boxer. I'm a foiler. So I'm going to do 2 times 2, that's 4. I'm going to do 2 times the square root of 3. So that's 2 square roots of 3. We're going to do 2 minus 2 times negative square root of 3, which is a negative 2 square roots of 3. And we've got a negative square root of 3 times the square root of 3, which is the square root of 9. Hey, that's 3. Great. Now you might see how this thing becomes real now. Look at this. We've got 2 square roots of 3 minus 2 square roots of 3. That's 0 square roots of 3. So the square roots go away right there. And then we've got this square root of 9 on the end. That's just a 3. So in the denominator, we just have 4 minus 3, which is 1. In the numerator, we've got 18 plus 9 square roots of 3, nothing to be done there. And so we're just going to leave that be. There's nothing to be done. 18 plus 9 square roots of 3. But hey, since this whole thing is being divided by 1, we don't really need that. We can just have our answer be 18 plus 9 square roots of 3. I would have written it over on the other side, but my face is in the way. And that's it. Keep in mind, you only need to do this conjugate stuff if they're being added, subtracted in the middle. Otherwise, the major thing that you need to know for today is that thing we did on the front, is if you have a radical in the denominator, you need to multiply the numerator and the denominator by that radical so that there is a rational number like 3 or 2 in the denominator. Thanks for watching.